In these two problems, you're asked to find 6 trigonometric functions using the point in the first example and only the angle measure in radians in the second example. So in order to do that, you have to understand how the unit circle works. In the first example, what we're going to use basically the concept of the relationship of the coordinates to the 6 trigonometric functions of t. So the first thing that I want you to notice is that you're given a triangle, and as you can see, this point, one of the vertices of this green triangle, lies on the circle. So this point actually has coordinates attached to it, right? And the coordinates are going to be x comma y. Okay? So any point that you plot on the circle will have points x comma y, just like this vertex of this triangle. So essentially, how do you use that? How do you understand that? So the reason why I drew this triangle is that so you can see that to get to this vertex, you have to have a base side measuring x units, and the top, the height of this triangle measuring y units, right? Because these are the essential coordinates in order for you to arrive at this point on the circle with coordinates x comma y. Now also notice that the radius of this circle, now notice that this is a circle with center O, and that corresponds to the origin in the xy plane that I drew, right? So the circle, unit circle, is drawn in the xy plane. Now what does a unit circle mean? Unit circle means that there's this radius of 1, right? There's a radius of 1. That's why the hypotenuse is equal to 1, right? Because that's the central radius. So in that sense, you should understand that if we have a triangle like this and we have an angle measure here, indicated in red, then the sine of this angle measure will be essentially opposite divided by the hypotenuse, which you probably remember. So opposite over hypotenuse is going to be y divided by 1. Y divided by 1 is y, right? That doesn't change, right? So let's draw, let's actually indicate 6 trigonometric functions without using these coordinates yet. So we know that the sine of t, using this triangle is equal, now t is what? T is going to be the angle measure in this case, right? T is going to be the angle measure in this case. So sine of t is going to be opposite divided by the hypotenuse, y divided by 1, which is equal to y. Cosine of t is going to be the adjacent side of this angle t divided by the hypotenuse, right? So it's going to be x divided by 1, which is going to be essentially x. Tangent of t is going to be the opposite side, y, divided by the adjacent side of this angle, x, right? So it's going to be y divided by x, right? That doesn't simplify. So, and then we're going to have what? We're going to have the cosecant of t, which is actually 1 divided by the sine, right? The reciprocal of the sine. So the reciprocal of the y, right? So 1 divided by sine of t, which is equal to essentially the reciprocal of y, 1 over y. Secant of t, it happens to be the reciprocal of the cosine, right? So 1 over cosine of t, which is essentially 1 over x. And finally, the cotangent of t is going to be the reciprocal of the tangent, right? So 1 divided by the tangent of t, which is essentially flipping this fraction upside down, right? So it's going to be x over y. So now using that concept, we can apply these rules for each of these trigonometric functions that we've derived using the unit circle here on these coordinates that were provided, right? So we're going to use this rule and find 6 trigonometric function values based on this, right? Based on the coordinates. So now we can indicate that we know that the sine of t in this case is going to be y. What is the y value here? Because this is what? This is x comma y, right? So that means it's negative 12 over 13, according to the rule that we've set up. Negative 12 over 13. The cosine of t is going to be x. What is the x here in the coordinate ordered pair? Negative 5 over 13. tangent of t is going to be y divided by the x. So y divided by the x. So this divided by this, right? So minus 12 over 13 divided by this fraction. But let's multiply instead of dividing and flip, right? Because we know if we divide two fractions, we can simply multiply them, but having the second one flipped, right? Using the algebra. Using the rules of algebra, right? So that's going to be minus 13 over 5 because we're multiplying, right? So we flipped it. So that's going to be what? The negatives cancel out, the 13s cancel out, right? So that means it's going to be a positive result, which is going to be 12 over 5, right? Because the negatives canceled out, two negatives. Now, cosecant of t is going to be 1 over y, right? So 1 over y, 1 divided by this. Now, when it comes to 1 divided by this, it means that you're essentially flipping this fraction, right? And the negative stays because there's no negative. There's only positive in the top. 1 divided by this is flipping this fraction, right? So it's going to be minus 13 over 12, right? We flipped it. Now, 1 over x is going to be flipping as well, right? It's going to be flipping this guy, 1 over x. So that means flipping this is going to be minus 13 over 5. Let me write this a little better. 13 over 5. Okay. And finally, the cotangent of t is going to be x divided by the y. X is this, or let's write that guy first. And then instead of dividing, because we're dividing by a fraction, let's multiply it, right? Save us some trouble. So instead of dividing by the y, let's multiply by 1 over y. 1 over y is going to be flipping this, right? So minus 13 over 12 because we're multiplying, right? Using the algebra. So now we know that the 13s cancel out, the negatives are gone because there are two of them. That means the result will be 5 over 12, right? 5 over 12. Now realize that 5 over 12 makes sense with the tangent being 12 over 5, right? Because the tangent, the cotangent was the reciprocal of the tangent, right? As it's noted here. So this happens to be the reciprocal, which is absolutely correct, of 12 over 5, right? Because if you reciprocate 12 over 5, you will get exactly the flipped fraction version, right? Which is going to be 5 over 12, right? So these answers make sense. You can also verify the other relationships like sine versus the cosecant. You understand that it's flipped, right? Minus 12 over 13 is flipped, right? Which is good. And also the cosine and secant have the reciprocal relationship. Minus 5 over 13 flips to be minus 13 over 5. Cool, right? So everything is absolutely correct. Now, in the second example, the approach will be similar, but then you will have to understand the relationships of the angles being involved here. So, in the same unit circle, we have to use not the coordinates this time, okay? Not the coordinates per se, but first we have to understand what the angle measure is. So we have to find the angle measure of the pi in this unit circle, and then find 6 trigonometric functions with respect to that angle measure pi. So first of all, I drew the angle measures, the 4 main angle measures that we're going to need to understand in order to arrive at the angle pi. So the first angle that you should be aware of is the angle between the positive x-axis and the positive y-axis, namely this angle, which is a right angle. It's 90 degrees and it corresponds to the angle measure of pi over 2 radians, right? Right? Now the next one is going to be a straight angle, a 180 degree angle, right? Which is determined by the x-axis and the positive y values, right? So quadrants 1 and 2 I'm talking about now. So this straight angle is 180 degrees and corresponds to pi radians, right? So now, you see the other angles I drew just for you to be educated about the rest of the angles here. The third angle is 3 pi over 2. It covers quadrants 1, 2, and 3, right? So if you start the angle from 0, right, and always angles are drawn in the counterclockwise direction, right? So you start here, you go here, and you stop there, right, using the blue line here, and that's going to be 3 pi over 2, the angle you create. And finally, all 4 quadrants will be covered by the angle, which is 360 degrees. If you go all the way around the circle and you come back to the same point, you start from 0, you wind up at 2 pi radians, right? So 2 pi radians corresponds to 360 degrees, all right? So now we only need the angle of pi, right? And the angle of pi, as I discussed, is the straight angle that we have in the orange color here. So the theta is pi. Now keep in mind, the theta, you can treat theta like a t here because t is the angle measure. Theta in this case is the angle measure. In the second example, it doesn't matter what you choose as your angle, symbol, as long as you make sense of it, right? So theta, I chose theta because I just love theta. I'm just in love with it in general. So I just love using theta as the angle symbol. So we need the pi. So we need to find the 6 trigonometric functions. Now, in order to understand the pi, you will need to understand the coordinates once again, right? So let's understand, when it comes to the straight angle of pi, which point corresponds to that pi? Obviously, you can see the first unit circle has a point -1, 0, right? So we're talking about for the entire example here, we're talking about one single point, -1, 0, right? And that serves as a point for the x and y, right? So this is an ordered pair that we need. So now what are we going to need? We know that sine of pi. Now, let's use that again. So sine of t was equal to y over 1, so that was equal to y. What is the y value? 0, right? Based on what we have here, so it's 0. Cosine of pi is going to be what? Is going to be x. What is the x? -1. Tangent of pi is going to be what? Y divided by the x. Y divided by the x is 0 divided by -1. 0 over -1, which is 0. Cosecant of pi is 1 over y. 1 over y is 1 over 0. Can we do that? I'm sorry, -1 over 0, so -1. 1 over y. No, I was right. 1 over 0, right? I looked at the x for some reason. 1 over 0, which is the y value. Can we do that? No, right? This is undefined. This is not allowed. Undefined. This is undefined. Now, the next one is secant of pi. Secant of pi. What is the secant of pi? Secant of pi is 1 over the cosine, 1 over x. What is 1 over x? 1 over -1, which is -1. And finally, the cotangent of pi is going to be x over y. -1 over 0. -1 over 0. Is that allowed? No, right? It's undefined because you can't divide by 0. Realizing how to understand the unit circle, how to use it, how to derive the relationships between the triangle sides here that I drew, will help you understand how to find the trigonometric functions, all 6 of them, using the ordered pair provided, a coordinate, right? Or finding the coordinates using the angle measure and understanding how the coordinates correspond with the angle measures in question in that same unit circle. So I hope this was useful. Thank you so much for watching, and see you in the next video.